Relationship between Kp and Kc. Since you know what exactly this Kp is and how it is expressed, and what is Kc and how it is expressed, we must know what is the relationship between these two. Because if one is given, we can calculate the other one also. The relationship between them can be derived from taking an example like A moles of A combines with B moles of B, giving you C moles of C and D moles of D. If all the reactants and the products are expressed in terms of their concentrations, it will be C to the power C, D to the power D, A to the power A and B to the power B, which can be written as number of moles of A upon V to the power A, number of moles of, this is C, number of moles of D upon V to the power, this will be also C and this will be also D, number of moles of A upon V to the power A, number of moles of B upon V to the power B. Fine. Now, if it is expressed in terms of Kc, we will be writing down as partial pressure of C to the power C, partial pressure of D to the power D, partial pressure of A to the power A, and partial pressure of B to the power B. Now, this partial pressures can be written in terms of their partial pressure expressions, and we know for this the partial pressure of, suppose we want to know for A, it will be number of moles of A Na upon V RT as from the ideal gas equation. Considering all the reactants and the products will be showing an ideal behavior, we can use this formula for finding out their partial pressures. Similarly, the PV will be NB upon VRT, and PC will be NC upon VRT, and PD will be ND upon VRT. So we can write the partial pressures formula of these four substances involved. So it can be written as number of moles of C upon V RT to the power C, number of moles of D upon V RT to the power D upon number of moles of A upon V RT, number of moles of B upon V, we have to multiply this one with RT to the power A, RT to the power B. Now, we can take out RT as common. So, in that case, this expression of Kp can be written as Nc upon V to the power C, Nd upon V to the power D, Na upon V to the power A, and B upon V to the power B. This RT will be actually having C plus D, and this RT in the denominator will be A plus B. Now, this RT can be taken above, and we know that this whole was your actually equivalent to your Kc, if you remember, whatever the expression we have already done earlier. So, we can write Kp will be equal to Kc RT to the power C plus D minus A plus B. This is usually written in short as Kc RT to the power delta Ng. This is what is the relationship between Kp and Kc is. Kp is equal to Kc into RT to the power delta Ng, where this your delta Ng is the C plus D minus A plus B. It means what? It is the difference of the sum of the number of moles of the gaseous substances of the product to the reactant. So, it is the summation of number of moles of gases of product minus summation of number of moles of gases of the reactant. And your R is your same your universal gas constant, whose unit will depend upon the unit of the Kp. If it is in terms of ATM, its value will be 0.0821 liter atmosphere per Kelvin per mole. Or if it is in terms of your bar, it will be 0.083, and this is the expression which we use to find out the relationship between Kp and Kc.